Hello everyone. Today we're going to be talking about the Doppler effect microwave motion sensor. We have the Doppler effect sensor right here, and here it is hooked up with its 3 wires to an Arduino Nano, and the Arduino Nano is currently hooked up to my laptop. Let's talk about the sensor first. What the sensor is it uses a special wave which it sends out, and based off of when that wave reflects off of something, the wave is changed, and based off of that change it's able to detect if there's motion or not. It is comparable to echolocation, in which bats and dolphins send out sound signals, and based off of how that sound bounces back, they're able to tell distance, shape, and size. But this is similar, but it doesn't do that. It uses a different method where it just measures how the wave has changed. Alright, let's take a look at the wiring. As you can see here, we have 3 wires coming out of the sensor, 3 different color wires. They are not labeled, nor did the package come with an instruction manual, so we can simply assume the fact that, based off of general knowledge, the black one is the ground pin, the red one is the VCC pin, or you could call it power pin, and the green one is the out pin, which you would connect to the digital input pin on the Arduino. As you can see, that is exactly what we've done here. I've used cable extensions, as these cables were female and not male, so we had to get male connectors to put them into the breadboard for the Arduino. They're all connected in different spots. You can see we have one to the 5-volt power, one to the ground, and one to the digital input. And from there, it's powered and connected to a laptop by my adapter. Alright, now it's time for the demonstration. As you can see here, I have some code running on the Arduino IDE, and what the code does, it just sets it up. It sets everything, initializes everything, and it starts the baud count at 9,600. I'll explain what bauds are in a second. We're going to the demonstration. So, as you can see here, all it does is set it's a digital input pin, so if the pin gives a high output, then we'll print no motion, which means there's no motion, and it'll do the opposite if the output is low. And there's a delay of 75 milliseconds right there. That's just to make sure the readings are stable. So as you can see, it's constantly printing no motion, but when I wave my hand, motion detected. Now for some quick details. As you can see here, there's 3 wires, and these 3 wires, I will show exactly where they want if you'd like to wire your own. As you can see here, the red wire, which I've connected to this little extension, will go to the little 5-volt pin on your Arduino Nano. Of course, it doesn't have to be on a Nano. If you have a normal Arduino, it'll go to the 5-volt pin wherever it is. And same thing, we're going to go back. We're going to go look at the black wire now. The black wire, which is the ground, will go directly to the ground pin on Arduino. It's just, I've used extensions because, of course, the cables were female and they couldn't go into the breadboard. Last thing, with the green one will go directly to the digital input pin. I've chosen D2. It doesn't really matter which one you choose. And that's pretty much it.